Hi, my name is Aloho, and I'm a graduate of MIT. This video will work on some problems to help you further understand chemical reactions. Our first question reads, after the first steps in writing an equation, the equation is balanced by A. Adjusting subscripts to the formulas, B. Adjusting coefficients to the smallest whole number ratio, C. Changing the products formed, or D, making the number of reactants equal to the number of products. So let's think about this. So we're trying to balance an equation, a chemical equation, which represents a chemical reaction that occurs. While we're balancing this chemical equation, we have to be careful not to actually change what's happening in the reaction, or it becomes something completely new. So which ones of these answer choices pretty much changes the identity of the chemical equation, thus changing the reaction? A for sure changes the identity of the reactants in the equation, adjusting subscripts in the formula. For example, if you have H2O or water within your equation and you wanted to adjust this subscript 2 to H3O in order to balance your equation, you've completely changed the identity of this molecule. So it's no more water, it's a completely new molecule. And so you've changed your actual reaction. So you can't do that. Let's jump down to C, changing the products formed. So that really doesn't make sense because your products formed depends on the reactants and the conditions that the reactants are placed in. So you can't really control that. So you can't change the products formed in order to balance an equation. And then D, making the number of reactants equal to the number of products. This doesn't really do it for us either because you're not balancing the equation. Just because you make the number of reactants equal the number of products doesn't mean you've balanced or conserved the mass within your equation, your reaction. For example, in the chemical equation for water, where we have 2 hydrogens plus oxygen to produce 2 molecules of water, we have an uneven number of reactants compared to products, although this equation is balanced. So we have 3 reactants, 2 hydrogen molecules plus 1 oxygen molecules, and we have 2 products, 2 molecules of water. If you were to make the number of reactants equal to the number of products, for instance, by removing 1 hydrogen, so you have 1 hydrogen, 1 oxygen, you won't be able to produce the 2 molecules of water that you need. So D isn't correct. You're not aiming to make the number of reactants equal to the number of products. What you are trying to do is adjust the coefficients. In this case, 2, 1, and 2, using whole number ratio so that you have the same number of hydrogens on one side of the equation as the other side, and likewise for oxygen atoms. So what you're looking to do in this example is have 2 times 2, 4 atoms of hydrogen on the left side, 2 times 2, 4 hydrogen atoms on the right side. So hydrogen is balanced. We have the same number of atoms of hydrogen on both sides. And for oxygen, 1 times 2, 2 atoms of oxygen, and then 2 times 1, 2 atoms of oxygen on both sides. So you're adjusting the coefficients, which are 2, 1, and 2, using whole number ratios in order to balance it. And the first step after writing the equation is to start out with the smallest whole number of coefficients in order for your coefficients to be reduced, just like reducing fractions. So our answer is B. Our second question reads, when a chemical reaction has reached a state of equilibrium, dynamic equilibrium, which of the following statements is true? A, the forward reaction has stopped. B, reactants form products as fast as products form reactants. C, reactants and products are present in equal concentrations. D, the position of equilibrium can be altered by adding a catalyst. Or E, the rates of the backward reaction is zero. So first of all, what is the dynamic equilibrium that it's asking us for? The dynamic equilibrium is when, during the reaction, like a chemical reaction, the forward and reverse reactions begin to occur at the same rate, leading to relative concentrations of products and reactants not changing. So basically, the reaction is still going on, but there's no net effect on the concentrations of reactants and products. So we can definitely get rid of A and E. The reaction is stopped and the rates of the backward reaction is zero because, as we just said, the reaction is still going. And we can also get rid of C because it's not necessary, the reactants and products don't necessarily have to be at equal concentrations, just at a ratio that's constant. So the ratio of reactants to products does not change while it's at dynamic equilibrium. It doesn't necessarily mean that they are at equal concentrations. D is interesting. The position of equilibrium can be altered by adding a catalyst. So this is something you should always remember, especially when we begin to talk about enzymes, which is a type of catalyst. Catalysts never, ever, ever change the equilibrium of a reaction. Their purpose is to increase the rate of reaction, but they never, ever change the equilibrium. So D is incorrect. So we're left with B. Reactants form products as fast as products form reactants, which is what we just said about the dynamic equilibrium. The rates of the forward and reverse reactions, which is forward reaction is reactants to products, and backwards reaction is products to reactants, they begin to occur at the same rate. So our answer is B. At dynamic equilibrium, reactants form products as fast as products form reactants. Our third problem reads, consider the equilibrium below. Which of the following changes will increase the concentration of HgI for 2+? And here's our equilibrium equation right here, and it's already balanced. So our options are A, increase in the concentration of OH minus, decrease in the concentration of H2O, increasing the mass of HgO, or adding a catalyst. So which will increase the concentration of Hg I42, which is on the right side of the equation. So in order to increase the concentration, you'll have to do something that pushes the reaction to the right. But remember, we're at equilibrium. So just that fact alone allows us to get rid of D, adding a catalyst, because as we just talked about, the catalyst does not change the equilibrium position. It can only affect the rate of the reaction. So if we start out with A, if we increase the concentration of OH minus, which is on the right side, so if we increase the right side, the reaction is going to want to go towards the left in order to balance. So if you have more on the right, we're going to want to create more on the left in order to balance the equation out. So that won't cause an increase in HgI4. So that's incorrect. B, decrease the concentration of H2O, which is on the left. So we're taking away from the left side. That's also going to make the reaction move to the left, because if we're taking away from the left side, we're going to push it to the left in order to compensate. And C, increase the mass of HgO. So that's increasing what's on the left side. HgO's here on the left. So we're increasing what's on the left. So in order to compensate, we increase on the right, so that's going to lead to an increase in the product that we're looking for. So the answer is C. Increase in the mass of HTO present will result in an increase in concentration that we're looking for.